Hi, we are going to start a series of robotics tutorial presented to you by J Robotics Technology Private Limited. Before we go into the deep core robotics tutorial, we'd like to see the basic stuffs like voltage, current and basic electronic components, how it works and all. It will be more exclusive like how it works inside, and we'll be breaking open the sections of electronic components and we'll see how it works. Before we go deep into the ocean, first we'll see what is voltage and what is current. First, voltage and current. As it goes by the dictionary definition, voltage is defined as the potential difference between 2 points. Current is defined as the flow of charged particles. It might be seeming like difficult to understand, but it's very easier to understand using some basic examples. First is like we'll go with an example. If you are going to cook a rotis or chapatis and you have cooked about some 20 to 30 rotis or chapatis in a cooking pan, for example. So this is a cooking pan, and after you are cooked, the temperature of the cooking pan will be somewhere around more than 100, because of the fact that even if you're going to put a water droplet over it, it's going to evaporate. So boiling point of water is 100, and if I'm going to go somewhere above it, I'm not going to be accurate, it's going to be somewhat approximate number. I'll go by 200 degrees Celsius. And human body temperature, it's going to be 37, which is 36.9. I'll go with 37 degrees Celsius. So I'm going to do an experiment. Don't try this at home, just to have a feel of how it is. And this example is not going to be a quantitative one, it's going to be like understanding the concept. Now I'm going to place my finger on this cooking pan. This is my finger. Once I touch this cooking pan, I'm going to feel invisible molecular transfer between myself and cooking pan. This invisible molecular transfer, which you feel as heat, can be same as current, can be understood as current. Actually, current is the same, like it is an invisible molecular transfer which happens whenever a voltage is present. Now voltage is defined as the potential difference between 2 points. Now if I'm going to see the potential of this, temperature of cooking pan is 200 and temperature of human body is 37, the difference is going to be the subtraction of these two. It's going to be 163. So if the difference is 163, I'm going to feel a large amount of invisible molecular transfer or large amount of flow of charged particles. And if doing the same experiment at the start of the cooking, for example, I'm just now cooked about some 5 to 6 or else 1 roti is sufficient, or else I have just started my cook. Now if I'm just started my cook, the temperature of cooking pan will be somewhere around 50 and my human body temperature will be the same. Now if I'm going to touch the same experiment like this, I'm not going to feel the same amount of charged particles or same amount of molecular transfer, because of the fact the difference between these two, 50 and 37, is going to be 13 alone. So this is 163 and flow of charged particles is high and flow of invisible molecular transfer is also less. If the difference is 13, the flow of charged particles or else invisible molecular transfer is very, very less, as I'm going to say, which is V is proportional to I if voltage increases and current increases. If there is one more example I'd like to say, voltage can be termed as the pipe diameter and the amount of water flowing in it is current. If the source is sufficient and if the load is also sufficient, we'll have a large amount of water flow in it. This water flow is known as current.